In a vehicle moving at high speed, airflow through the radiator cools the coolant. But at low speed or when the engine is idling, extra airflow comes from a fan. Fans can be driven in different ways. More and more modern vehicles now use an electric fan. Air-conditioned cars often have extra fans. Electric fans can be behind the radiator, in front, or both. This arrangement would be difficult with a belt-driven fan. Some fans can be driven from the crankshaft. When an engine is mounted longitudinally, its fan is usually mounted on the water pump shaft. The drive belt then turns the water pump and fan. Some use a hydraulic link from the power steering system. Fan blades can be rigid or flexible. Rigid blades tend to be noisy and use more energy. This noise can be reduced by using irregular spacing of the fan blades. Some vehicles use a shroud to direct all of the air that the fan moves through the radiator core. At high speeds, plenty of air is already flowing through the radiator. If the fan is always working at full speed, it's a waste of energy. And since the engine drives the fan, it's a waste of fuel too. What's needed is some way to control the fan. A heat-sensitive switch in contact with the coolant can work like a thermostat and turn the fan on and off according to coolant temperature. Another way to alter the speed of the fan is with a viscous hub. This type of fan slips when it is cold, but as the engine heats up, it grips more and more. Overheating can seriously damage an engine, so having warning of trouble is obviously useful. A device that's sensitive to engine temperature sends readings to a temperature gauge or a warning lamp. To give an accurate reading, this sensor must always be immersed in liquid. Indicators that measure coolant levels can give warning if the levels fall too low. If a coolant boils, it can be as serious for an engine as having it freeze. Boiling coolant in the water jacket becomes a vapor. No liquid is left in contact with the cylinder walls or head. Heat transfer by conduction stops. Heat builds up, and that can cause serious damage. One way to prevent this is with a radiator pressure cap that uses pressure to change the temperature at which water boils. As coolant temperature rises, the coolant expands and pressure in the radiator rises. It soon rises above atmospheric pressure, and that lifts the boiling point of the water. Engine temperature keeps rising, and the coolant expands further. Pressure builds against a spring-loaded valve in the radiator cap until, at a preset pressure, the valve opens. In a recovery system, the hot coolant flows out into an overflow container. As the engine cools, coolant contracts and pressure in the radiator drops. Atmospheric pressure in the overflow container then opens a second valve, a vacuum vent valve, and overflow coolant flows back into the radiator. And that stops atmospheric pressure collapsing the radiator hoses.